Hi children, welcome to my channel Fusion Science. In this video we are going to learn about types of chemical reactions and difference between oxidation and reduction. These two concepts are very important for your board exams. So let's begin our video. We'll start our video. But before getting into the main topic, we have to be perfect with basics, right? So let's learn some basics about our concept today. Okay now? What is this? Chemical reaction. So today our topic is about types of chemical reactions, right? But first of all, you must know what is chemical reaction. No? In our previous videos, it is already present. But even though, just I am giving a recall. Okay? So chemical reaction. It is a process between two elements or two compounds or element and compound to form a new compound. Okay? So chemical reaction is a process. So keep that in your mind. Chemical reaction is a process which is happening between two elements or two compounds or element and compound. Okay. So some process is taking place between these two and as a result they are giving a new product. Okay. See. It is a process in which two elements or two compounds or one element, one compound, okay, react with each other and forms a single compound. Means here two elements are reacting with each other and forming a single compound. Let us take one example. C plus O2 gives rise to CO2. Here C means carbon, O2 means oxygen. So here carbon and oxygen are reacting. So this plus symbol indicates reaction. Okay. This carbon and oxygen are reacting with each other and forming carbon dioxide. Okay. So here this arrow mark indicates forms or gives. Okay now. So this is chemical reaction. Simply you can remember in your mind, it is a process which is happening between two elements. Okay na? So next topic is chemical equation. Chemical equation. Chemical equation means the symbolic representation of this whole process. We call it as a chemical equation. Nothing but, see here we are saying carbon is reacting with oxygen and forming carbon dioxide. You said that in words, right? If you write that in the form of symbols, that we call chemical equation. Simply the symbolic representation of a chemical reaction is called chemical equation. That I have shown here. In the chemical reaction, we said that carbon is reacting with oxygen and when these two are reacting with each other, as a result carbon dioxide is formed. We said this whole process in the form of words now. So if you say that in the form of symbols, like carbon means C, oxygen means O2, carbon dioxide means CO2. Okay. So if you write in the form of symbols, that we call a chemical equation. But there are some rules for writing a chemical equation. What are those? What is the main rule here? LHS is equal to RHS. LHS is equal to RHS. LHS means, as you all know, it is left hand side. RHS means right hand side. But in left hand side what must be? Reactants. Is equal to symbol is there, no? So that is equal to is nothing but result, na? So is equal to symbol we represent here with arrow mark. Okay. In RHS side what should be? Products. So now in the place of reactant side what we have to write? So we have to write what are the elements participating or what are the elements combining with each other or what are the elements participating in that chemical reaction. Those should be written in the place of reactants. Example, carbon and oxygen. Both of these are participating in that chemical reaction. That's why we have to write C plus O2. How many are participating? Those many we have to write. But there should be a plus sign in the middle. So this plus sign indicates that the reaction is taking place over there. Clear? So C plus O2 gives rise to, what is the product they gave? CO2. Okay, so this is the method of writing a chemical equation. Clear, children? And still you can mention their states. States means in which state it is, either solid, liquid or gas. In which state it is present, that state you have to mention. So where we can mention that? Down over here. So what is the carbon state? Carbon is in solid at room temperature. So we have to write as S. O2 is gas and CO2 is also gas. So this is the exact form of writing a chemical equation. Clear, children? And some more we can add in this, but when I explain the types of chemical reactions, in that I will explain. Okay. What is our main topic today? Types of chemical reactions. Actually, there are 4 types of chemical reactions. These are the main types of chemical reactions, like combination reaction, decomposition reaction, displacement reaction and double displacement reaction. Let us learn about them each now. So first we'll go with combination reaction. Combination reaction. In the name itself it is present. Combine. Combine means here 2 elements are combining with each other. Okay. So here 2 elements are combining with each other and forming a single product. They forms a single product. Okay. It is a reaction in which 2 elements or 2 compounds react. React means they are combining. React with each other and forms a single product. You may get doubt. It's like chemical reaction definition only. Yes, it is chemical reaction definition only. Both combination reaction and chemical reaction both are same. So let us take one example here. Mg, magnesium. So this magnesium is available in the form of ribbon. So this ribbon must be plain silver color. This ribbon not only in silver color, nowadays it is available in brown color, yellow color. So like this. But take a ribbon, it should be very clean. There should not be any white spots or anything on it. If there are white spots, we say that magnesium ribbon is oxidized. So it will not give us result faster until we remove that oxidized part on the ribbon. See, actually magnesium ribbon will be like this. Okay, na? Somewhat in silver color. So sometimes we can observe some white color spots like this. So this spots indicates that this magnesium ribbon is oxidized. When this magnesium ribbon is oxidized, it won't participate in combustion fastly. It will, but it takes a lot of time. So what we have to do to make it faster? We have to remove these white spots on the magnesium ribbon by using a sandpaper. By using a sandpaper. Then we have to use the magnesium ribbon for the chemical reaction. Okay, now. So now we took magnesium ribbon and we burn this magnesium ribbon with the help of some matchstick or burner or something else. We are burning it. So when we are burning it, are we giving any oxygen to that magnesium? No. There is a oxygen in the atmosphere. That is the reason this magnesium ribbon is burning. Okay. From where it is taking that oxygen? From the atmosphere. From the atmosphere. So this magnesium is taking oxygen from the atmosphere. We are not exposing any oxygen to this manually. It is taking from atmosphere only. So we can write in the equation magnesium is reacting with oxygen present in the air. So these two are reacting. As a result, what we get? So now this magnesium ribbon is burning. Okay. So when it is burning, we can observe some white dazzling fumes. White dazzling fumes, and this magnesium ribbon will turn into some powdery structure. That's nothing but ash, and this ash formula will be MgO, magnesium oxide. So I get doubt. You said already that magnesium should not be oxidized. We have to remove that. then only it will participate in the combustion ani. Yes, of course, like that only it will participate in the combustion. But when it reacts with oxygen present in the atmosphere, it completely turns into ash form. Even that ash formula is NgO, magnesium oxide. Okay, so now see guys, is this equation balanced? Is this equation balanced? No. See, here one magnesium is there. Here also one magnesium is there. So it is balanced. Here how many are there oxygens? 2. But here 1. So I want 2 over here. I want 2 oxygens here. What I should do? Already this video, this balancing of equations video I have done in our channel. So at the top of this video there will be that balancing of equations cards will be. So open it and watch. Then watch this video. Okay guys. See. So now I want 2 oxygens over here. So for that I can add 2 over here. Okay now. Yeah. So now here we have 2 magnesiums and 2 oxygens. But here we have only 1 magnesium. So I want 2 magnesiums over here. What I can do? I can add 2 here. Okay. So now check the equation. How many magnesiums are present? 2. Here how many oxygens are present? 2. So here how many? 2 magnesiums and 2 oxygens. So here LHS is equal to RHS. That is the main principle of chemical equation, means that should be balanced in both the sides, LHS side as well as RHS. Okay. So now see, so understood about combination reaction. Here these two elements are combining with each other and forming a single product, Okay. Now let us get into the another chemical reaction, that is decomposition reaction. Basically we say chemical decomposition reaction, chemical combination reaction, chemical displacement and chemical double displacement. But every time no need to write chemical, so we simply say decomposition reaction. So decompose. See, decomposition reaction. Decompose. Decompose means in biology you will learn that complex molecules will turn into simple molecules with the help of some bacteria present in the soil. Somewhat you will learn in biology, right? So decompose. Decompose means splitting up into its constituent elements. Okay. So decomposition reaction says that here one reactant will split up into its constituent elements. What is this constituent elements? Means here the reactant is compound. But in the previous reaction, combination reaction, there the reactants are elements. But here the reactant is compound. So this compound is splitting, means breaking into its constituent elements, means with what it is made, into those elements only it is turning. Okay. So will it turn naturally? No. Here it takes the help of some elements like heat, sunlight and electricity. Okay now, let us check that first. Decomposition reaction. It is a reaction in which single reactant. What is the reactant here? It is a compound. Reactant splits up or breaks down into its constituent elements. Let us take one example here, that is AgBr. AgBr is nothing but silver bromide. Here it is a compound, right? You can clearly say it is a compound of silver and bromine. So now this silver bromide is splitting up into its constituent elements. With this silver bromide will breaks up into silver and bromine. Okay. See. Ag plus Br2. Ag plus Br2. So when this compound is breaking, we are getting the same elements what are present in this only now. That is why we said reactant splits up or breaks down into its constituent elements. Okay, constituent elements means what are the elements present in this compound. Into that elements only it will split up. But it won't split up naturally. It takes the help of some elements called heat, sunlight and electricity. Here this silver bromide will be in the color of silver. So what is happening? So when this silver bromide is exposed to sunlight, so you'll be having in your textbooks one diagram. So we'll be keeping some silver bromide in a cup and exposed to sun. So this silver bromide turns into grey color, somewhat greyish, because it completely broken down into silver and bromine. Okay now? So it is taking the help of sunlight. That is why this decomposition reaction we called as photolytic decomposition reaction. What is that, guys? Photolytic decomposition reaction. Photo means sunlight. In biology you will read photosynthesis. With the help of sunlight it produces food. Yes or no? So in the same way, photo means sunlight. So with the help of sunlight, this compound is breaking down into its constituent elements. Clear, children? So now in decomposition reaction there are three subtypes. That is photolytic, what we read now. Next is thermal decomposition reaction and electrolytic decomposition reaction. Let us check that two also. Okay. So another example is CaCO3. This is calcium carbonate. When you heat this calcium carbonate, it turns into CaO plus CO2. So when you heat this, you have to write that elements up of this arrow mark. Okay na? Heat. You have to write in the up of the arrow mark. Okay, children. So CaCO3 is turning into CaO plus CO2. Clear? So this decomposition reaction is taking place in the presence of heat. That is why we call this as thermal decomposition reaction. Thermal decomposition reaction. Clear? Now we'll go for electrolytic decomposition reaction. Like example H2O. We took water and we passed some electricity through water. So when you pass this electricity through water, this water will split up into H2 and O2. So this process we call electrolysis process. Hope you all remembered it. Hope you all know that. Okay. So now this reaction can be called as electrolytic decomposition reaction. Electrolytic decomposition reaction. Here, see, single reactant. This is reactant only now. Single compound is splitting up into its elements. Okay. Yeah. Now, let us learn about one more reaction here. Combustion reaction we learned about exothermic reaction, right? Now we learn about endothermic reaction. Why it came means, see here, in CaCO3, this is one compound, but it is in the place of reactant side. Now it is splitting up into CaO plus CO2, as they look like reactants, but they are in the place of products. So we have to call them as products only. Now this is happening in the presence of heat. Okay, next. AgBr, silver bromide. This is turning into silver and bromine. So now this happened in the presence of sunlight. Okay, next H2O is turned into H2 plus O2. So this is done in the presence of electricity. Okay now. So all these reactions are done in the presence of something. These are coming from external source. Either you are giving heat, you are heating that object or you are heating that compound. So this is taking sunlight from natural. This is taking sunlight from nature, and you have passed electricity through this water. So this is the external source. Okay, means this is combining with this heat. Combining with this heat means it is absorbing heat from the nature, absorbing sunlight from other source, or absorbing electricity from other source, means it is taking inside and then splitting, right? So it is taking inside. That is why we call this as endothermic reaction. What is that? Endothermic reaction. Endo means inside. Thermic means heat. It is taking heat inside. It is taking heat into itself. Okay. From sunlight what we get? Heat only. From electricity what we get? Heat only. Na? It is taking heat inside. That is the reason we call this equation as endothermic reaction also. Okay na? So can we say all decomposition reactions are endothermic? All combination reactions are exothermic? No. Not all combination reactions are exothermic. Not all decomposition reactions are endothermic. Clear, children? Now let us get into next interesting topic. The next most important reaction is displacement reaction. I'll tell you one easiest example, classroom example. You and your brother both are there. Okay na? Your younger brother is having 10 chocolates. You are having 8 chocolates. You are so jealous that he is having 10 chocolates. So what you do? So your elder no, that you are strong. So what you do? You just slap him and take the chocolates, right? So means you are having a strength, more strength, but your younger brother not having more strength. If he has strength, he will just give you another slap. But now see, this is just a general example. Coming to this, see, in this reaction, highly reactive metal displaces the least reactive metal. What is this reactive? Reactive series, Babre Bab, reactivity series. This is very important, guys. I am working on it. So I'll post one reel how to remember that reactivity series easily. So first let me give you some reactivity series here. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, and next copper, silver and gold. There are so many in the middle, guys. In the place of comma, we'll write greater than symbol. So see, potassium is greater than sodium. Sodium is greater than calcium. Calcium is greater than magnesium. Magnesium is greater than aluminium. What is the least one here? Gold. Okay, but this is least than this, na? This is least than this, no? Yes or no? So this is one reactivity series. As we are going down, the reactivity of the element reduces. The reactive nature of the element reduces. Here the most reactive metal is potassium. It is a very highly reactive metal. Least is gold, but very precious and costly, right? So gold is the least reactive metal. Okay. So now we took one example. Fe means iron. CuSO4 means copper sulfate. Okay. So here let us check where is iron and where is copper sulfate. Iron is here and copper is here. In these two, which is highly reactive? Iron, right? Which is least reactive? Copper. Okay. Iron is highly reactive than copper. Okay. So here copper is having something extra rather than iron. So now what this iron will do? This just slap this copper and takes sulfate. Means just it displaces copper and takes sulfate and forms ferrous sulfate. That's why I wrote here. In this reaction, highly reactive metal displaces means change place, displaces the least reactive metal. It just removes copper and react with the sulfate. This iron react with the sulfate and forms ferrous sulfate. Then where the copper will be? It stays alone. Because it is not having that much strength to fight with iron. That's why it stays alone. Right, children? Understood? There will be one experiment in your textbook. Take one beaker. In that beaker, pour some copper sulfate solution. So in that, place some iron nails. Think these are nails. Okay? Don't mind about my diagram. Okay now? So now these iron nails in the very new state, they will be steel color, somewhat shiny, right? So whenever you keep this in the copper sulfate solution, this iron just displaces this copper and react with sulfate and turns the whole blue color solution into yellowish. Okay, now this steel iron will turn into brown color. It's nothing but copper will deposit on this nail. Okay now, what the iron present on this nail comes into water and reacts with sulfate. What this copper will do? This copper will take the place of iron there. That's it. That is only happened here. This iron react with sulfate and formed as FeSO4 and copper is staying alone. So this is displacement reaction. Okay now? Next is double displacement reaction. Yeah. This reaction can also be called as, guys, single displacement reaction because only one time it is changing their place. But in double displacement reaction, they change their places twice. Okay, means they exchange their ions. Let us check that. Okay, double displacement reaction. In this reaction, compounds exchange their ions. Let us say take some compounds like Na2SO4 sodium sulfate plus BaCl2 barium chloride. Yeah, let us take two compounds here, sodium sulfate and barium chloride. So when these two are reacting with each other, they don't like their partners. For example, your mommy bought two dresses for both of you. Okay, what she gave you did not like. What you people will do? You just exchange now with each other. In the same way, this has happened. Here, sodium will be with sulfate. Actually, it should be with sulfate. But what it will do? It just dislikes sulfate and reacts with the chlorine. Okay. And this barium, what it will do? If it reacting with chlorine, what it will do? It will react with sulfate. They just exchange their partners over there. So now it forms 2NaCl plus BaSO4. BaSO4. Now this BaSO4 will be in the solid state. See, in your textbook, they'll give one example like this only they'll give you, I think, sodium sulfate and barium chloride. When you mix these two, you can find some solid substance forming in the water, in the liquid substance. Okay, this liquid is not, actually we take both liquids only. Sodium sulfate will be in the liquid state, barium chloride also will be in the liquid state. But when you mix these two, what is happening? Like this, the compound is, okay, somewhat watery and somewhat solid state. Okay, this solid state we called as precipitate, which is insoluble in water, So the remaining whole part is water only some is solid because this is not soluble in the water. So that insoluble part only we called as precipitate. So in these two compounds, when these two compounds exchange their ions, NaCl will be in the liquid state, BaSO4 will be in the solid state. When the compound is in the solid state and the other compound is in liquid state, we represent that solid compound with the down arrow mark side. Okay, so this down arrow mark indicates that is a precipitate, that is insoluble substance. Okay, now this equation, this reaction can also be called as precipitation reaction. What is precipitation reaction? A reaction in which a solid substance is formed which is not soluble in water. Which is not soluble in water. Clear, children? Understood? So, double displacement reaction means in this reaction, compounds, these two are compounds only, na? Okay, or you can say reactants also. Reactants exchange their ions and forms new products. New products. Clear, children? In this reaction, compounds or reactants exchange their ions and forms new products. See, Na2SO4 is in liquid state. BaCl2, it is in liquid state. Both are in liquid state only. But why after they exchange their ions, why we are getting this here? Because it is insoluble. So that insoluble substance we call it as precipitate. In which reaction that insoluble substance forms, that reaction we call it as a precipitation reaction. Okay, and that that reaction can also be called as double displacement reaction. When this double displacement reaction takes place, then only this precipitation reaction automatically takes place in that. Clear? Fine. So we are done with types of chemical reactions. We learned so many today, and still 2 more are balanced. I appreciate to your patience to listen till now, and 2 more are balanced. Listen those also, guys. Okay. Now the next topics are oxidation and reduction. So already we learned one question very easily and in a very simplest way. Whether you understood or not, I don't know. I hope you understood about all the types of chemical reactions. Okay. Now this is the second important answer, oxidation and reduction. Oxidation. Oxidation means gain of oxygen or loss of hydrogen we call as oxidation. That I'll explain you. Now reduction. Gain of hydrogen. Gain of hydrogen and loss of oxygen we call reduction. Okay, now see, let us see examples for these. Already we took one example, 2Mg plus O2 gives rise to 2MgO. Initially, for this magnesium, is there any oxygen present with this? No. So what it did? So it took oxygen from the atmosphere and reacted with it and formed magnesium oxide. Means it is oxidized. So here oxygen is added to the magnesium. So this is a oxidation reaction. This is a oxidation reaction. Means gain of oxygen is done. Okay. Now, let me tell you one more example for oxidation. Take copper. Now this copper is oxidized. Means you are heating copper. So this copper is reacting with oxygen present in the atmosphere and forming cupric oxide. Now copper is oxidized now. Actually copper must be in brown color. But when it reacted with oxygen, it turns into black color. Okay. Now the copper is oxidized. Understood? So now see. Let us take the same example and I'll explain you reduction. CuO plus H2. Gain of hydrogen. Gaining is nothing but adding. Okay. Here gain of oxygen means gaining is nothing but adding here also. CuO plus H2 gives rise to Cu plus H2O. Cu plus H2O. Here you have to remove this oxygen. You have to remove this oxygen. For that what you are doing? You are adding hydrogen to it. Adding hydrogen or removing of oxygen, both are nothing but reduction only now. So when you are adding hydrogen, what is happening? It is forming water with O. Okay. So Cu plus H2O. Okay. Now actually here oxidation is done and this oxidized compound is turning into again normal element. So this whole process can be called as redox reaction. Actually in a chemical reaction, oxidation and reduction happen simultaneously. When this oxidation and reduction are taking place in the same chemical reaction, then we call that as a redox reaction. Redox, reduction plus oxidation. Reduction plus oxidation. Either oxidation will take place first and then reduction takes place. So if these two happen simultaneously, then we call that as redox reaction. Don't read it as redox. It is redox. Okay. So oxidation means what? Adding of oxygen. What we did over here, that. Reduction means adding of hydrogen. What we did here? Adding of hydrogen means to the compound we added hydrogen. So this is reduction. So when these two are happening simultaneously for a single element, then we call that whole equation as redox reactions. Clear, children? Fine. Here in the next topics I will explain about rancidity and corrosion. So then you can understand more about oxidation. Okay na? Hope this video is helpful to you. So if you like the video or if you understood the concepts clearly, subscribe and like it. And share the video and wait for the next videos. Bye guys.